Hello, guys. My name is Engineer Holiday. We want to talk about pressure today, and we are talking about introduction to pressure, and that is want to just introduce it today. This is another topic. I think we are done with density. So first, what is pressure? What is pressure? Pressure is defined as the force per unit area, as the force per unit area. So force is what? Is divided by what? Cross-sectional area. So in that case, what do we say? We say pressure is defined as the ratio, that is another way, of force and cross-sectional area. Three things have been mentioned here. We have mentioned pressure, we've mentioned force, and we have also mentioned area. Now, the pressure itself, which is we define as force over area mathematically, F over A. Now, what is a force? Force is measured in Newton. Why what? Area is measured in meter per what? Meter square. That is to say that the unit of pressure is Newton over meter square. So the unit of pressure is Newton per meter square. Now, which is also what? Which is also called what? Also called what? Pascal. So PA is the word. So when I say 1 Newton per meter square is also known as 1 Pascal. PA. Anytime you see 1 Pascal, you are talking about what? 1 Newton per meter square. It was named after a man called Pascal. Was the one that first talked about pressure. Now, having done that, don't also forget that pressure we are talking about here can also be likely to be what? Pressure equal to what? Weight of the body involved divided by what? Area. It can also be called weight of the body divided by area. Now, majorly in this introduction, we are trying to consider what? Pressure more in solid. We are trying to consider pressure more in solid, because we are still going to talk about pressure in liquid. So this is the introduction part. Now, don't forget, all of us, we all understand, if you don't know, Newton is the same thing as kilogram meter per second square. Remember, the unit of Newton, force is mass times gravity, or mass times acceleration. That's what we call force. But the acceleration we are talking about here is acceleration to gravity. So if this one is force and mass, which is kg, times acceleration, which is what? Meter per second square, they combine it, you are going to have what? Kg meter per second square, which is same as Newton. So that means Newton is same as what? Kilogram per meter square. Kilogram meter per second square. Now area is what? Meter square, which is what? For area. So if you now combine them together, so pressure is what? In terms of fundamental what? Units, like kilogram, meter, and second. We can say that force equal to kg meter per second square divided by meter square. And if you do that, what will happen? This will cancel this, remaining m, so we're going to have it as what? Kg per meter per second square. This is equal to what? Pressure. So dimensionally, pressure is what? Equal to M. M is the capital letter for a dimension for kg. L minus 1 and what? C raised by minus 2. Don't forget seconds. The dimension for time is T. Dimension for mass is M. Length is what? L. So that is what? What are other things that have the same unit as pressure? What are the other quantities in physics that has the same unit as pressure? E.g., quantities what? With the same what? Units or dimension as pressure. One of them is what we call the Young modulus. Young modulus have the same units as what? Pressure, which is what? Also measured in Newton per meter or square. Number 2 of them is what? Is stress. Stress is also measured in Newton per meter square, because in the examination or they can ask you to list other quantities that has or have the same units as pressure. Stress is number 1. The Young modulus is number 2. Remember that pressure is a scalar. Pressure is a scalar, but stress is a vector quantity. What is a vector quantity? Is that quantity, is that physical quantity that has magnitude, size, and what? Direction. Though at a particular level of this particular video, if you check my video vector, I told you stress actually, in the real sense, in its reality, is a tensor quantity. There are 3 quantities in physics: the vector quantity, the scalar quantity, and the tensor quantity. So go and watch that video. I'm not talking about that now. Go and watch on that vectors and scalar on my playlist. You and get to what? Understand why I say stress is not, in reality, is a tensor quantity. Now, after knowing all this, don't forget also that the unit I say is equal to what? Newton per meter square, which is what? The same as what? Pascal. What about other units that we have? Don't forget 1 ATM is equal to what? 101325, which approximately would be rated as what? 1, 2, 3, 4, 5. It has 10⁵ Pascal. Let's take on 1 ATM. That means in examination, there's a 1 atmosphere. ATM means 1 atmosphere. 1 atmosphere mean what? Then another thing again, 1 what? Bar is equivalent to what? 101325. 101325. Record that. Please take note of that. 101325 Pascal or Newton per meter square. I've also told you that what? 1 Newton per meter square is equal to what? 1 Pascal. 1 Pascal. Also recall that 1 what? Millimeter mercury equal to 1 to the selling. 1 to the selling. The short form is what? To TORR. Then don't forget that 1 mm mercury is equal to 13.6 millimeter mercury of water. Of water. 1 millimeter mercury, anytime you see Hg, mean what? 1 what? A mercury. Anytime you see H2O means water. So 1 mm mercury is equal to what? 1 what? 13.6 what? Millimeter what? Of water. Don't forget that. Also, lastly, where I want to give it for unit for that, is 760 millimeter mercury is equal to what? 1 atm. Now listen, so good. Let me go back to that formula after giving units. Now don't forget that pressure that I told you is what? Equal to mass times gravity over area. Listen and listen so good. Weight equal to what? Mg. I told you the force can be likened to the weight. Is that still correct? Also, sometimes in the question we might not give what? They might not give us mass. Recall in density and octors. Go and watch density and octors. The last class we did. We cannot be going back to all those things. I told you. Then mass is what? Density times what? Volume. Remember that we say density equal to mass over volume. If you remember vividly, that was the first definition I gave when I was defining what? Density. Then when you make density the mass the subject of formula, we're going to have what? Density times volume as mass. Then substitute it here, we're going to have what? Pressure equal to what? Density times volume. That means in place of mass, you place that then times gravity over area. Recall, area depends on the shape. If they give you radius, area can be equal to what? Pi r square. If they give you radius of the shape, the area may be area that the force exerted on it. The force is exerted on an area where radius is given. A circular shape, a circular region. It becomes what? Pi r square. What about if the pressure force is applied in a square region? Area becomes L square. Please take note of that. If the force applied is what? Per unit an area, a square area. If it's a square area, your area of a square is L square. If it's a circular area, it's pi r square. If it's a rectangular area, it becomes length times breadth. So area can take any word formula based on the what? The shape of the area where the force. The force is not just normal force, but perpendicular force or normal what? It's not just ordinary force, but we call it, sometimes we call it perpendicular force and what? Or normal force. Normal force is what is common. Now, from this formula, you can actually see that we are able to conclude that pressure is equal to force over area. Pressure can be weight over area. Pressure can be what? Mg over area. Don't forget. Pressure can be density times volume times gravity over area. Please don't bring pressure equal to what? Density times gravity times height. That will be considered under pressure in fluid. Now, let me explain the practical application of this. Practical application of this. Increase in pressure. Increase in pressure is as a result of maximum force applied per unit what? Small what? Area. So that is to say, a maximum pressure, let me put maximum pressure. Let me put it that way. Maximum pressure, it can be what? Is as a result of maximum force applied per unit what? Small what? Area. That is to say, the higher the force per unit what? A smaller area is what? We have what? We have a what? A maximum pressure exert. Example of this is your sharp knife. Look at this knife now. Look at the sharp knife now. Now, if this is the knife now, and I want to what? I want to penetrate something. Let's say I want to penetrate this place, this surface area, well, with this sharp object, this sharp knife. Now, looking at it, I don't think I need to apply much pressure in this case now, or higher force. So this one is what we call minimum pressure. Minimum pressure. is as a result, as a what? Result of what? Minimum force applied per unit what? Per unit what? Bigger what? Area. So that is to say, if the area is what? Very small. Now what we have applied here now is what? Smaller area. If you check the knife as the what? Is occupying what this the area is occupying on this surface is small compared to what? The force. So if you apply a bigger force now, it will produce a higher what? Pressure. So if I push this thing inside, the pressure will be high on this body. For example, if this one is a human being, for instance, you understand? If I penetrate the skin of that human being with that knife, it will just begin to bring out blood. The blood will be rushing out. You know why? Because this edge is sharp. So this one can even kill somebody quickly because of what? The smaller area. So the smaller area, example of a smaller area, higher pressure is high heel. Check our ladies. It is not all ladies that can put on a high heel. Yes, which narrow what? Heel, narrow heel. Is not when I say narrow heel, I mean heel that is what? That occupy a smaller area. For example, a heel of this type. Let's say this is the lady's leg, and this is the shoe. So can you imagine the sharp heel like this? Most ladies, they are able have to hold their boyfriend or girlfriend, husband, before they can even climb a hill. Because why? If they are not careful, they will just land with their back. So that's why you see some people, they say, I don't like high heel. It's a lie. It's because the heel occupy a what? A smaller what? Area. Whereby if you put the what? Let's say we put it on a wooden what? A wooden floor. You will see an impression of the heel on a wooden floor. You will see the mark. The wooden floor is just like a soft floor. So because of what? The heel is sharp. And it will produce a what? This heel will produce high pressure, high force on the floor, and what? Small area. Please take note of that. But let's take a what? Another heel that is a wide heel. A wide heel. A heel that is wide. Let's say we take a what? Look at this heel now. Now this is what? The floor. This is a heel now. Now this is the shoe of the lady. Now this heel is wide. So it will what? Because it has a wide word heel. This is what? A narrow word. A narrow heel. It will produce a what? This will produce what? A lesser what? Less pressure on the floor. Less pressure on the floor. Then less force on the floor. And what? As larger what? Large what? Area. I want to give an example. You know, you understand now. If a lady with high heel mistakenly step on you, on your leg, the way you will shout, you will know that something has stepped on you. Just like, let's assume that your leg is the floor, and let a high heel step on you, and let a flat heel, a wide heel step on you. You will feel. Let's see the one that you will shout more is the high heel. That shout is as a result of high pressure. The high force has been exerted on that leg. That leg is likely to be swollen. There is smaller area. But compare what? a lesser what, wider what, will produce lesser pressure, lesser force, and what, larger what, area. Let's assume elephant. I can ask you a question. Type your answer. An elephant, does it exert, which of these category can you place the leg of an elephant? I want to see your answer in the report. The legs of an elephant, which category can you place it? This category of high pressure, high force, small area, or less pressure, less force, and large area? Please engage the comment section and let's see what you can do. So now, an incense, what category can we classify the legs of an incense? Is it this category or this category? The legs of an incense, is it this category or this category? Now let me now use a lady. A lady lie flat. A lady is standing with her two legs. A lie flat on a particular wall. She's now standing with her two legs, and she's standing with her toes of her two legs, and she's standing with a toe of one leg. Which of them will have more pressure? So I believe that the answer should be what? Standing on her toe with one leg, because all the weight of her body will be on that leg. If daddy and mommy want to punish you, they will say stand on your toes. Before you know, some of you will be crying. Even I cannot do it now. I'm already feeling the pain, because all my weight will focus on that. Then followed by standing with on your toes with two legs. Then followed by standing with your two legs. Then lying down. When you are lying down, you are flexing now. You are enjoying. You are relaxing. So the pressure will be what? More. Because the weight of that lady or that man will still remain constant. But the weight of the man will remain constant. But the area will be changing, because when you start with his toe, with one foot, with her toe, she is exerting smaller area with higher pressure. So the higher the pressure, the smaller the area. And the smaller the larger the area, the smaller the pressure. Please take note of that. Very, very important. Most of the times, the weight is always kept constant. I'll just give you an example of that. So we have answered that question. It's a very vital question which many of you should understand and take that. Now, pressure, I told you, is a scalar quantity. Pressure is a scalar quantity that has what? Magnitude, but no what? Direction. Pressure is a scalar quantity that has magnitude but no direction. Pressure is a scalar quantity that has magnitude but no what? Direction. Pressure is a derived quantity. Pressure is a derived quantity, meaning that we just derive the quantity. Now I gave it dimension, I've cleaned it. With dimension of pressure, we derive it, because it's made up of what? It's made up of what? Fundamental quantities. You understand? All these ones are what? Combination of what? This is length and breadth. This is what? Length and breadth in this place is what? Fundamental. This is what? Mass, fundamental. Gravity, derived. Because so we now combine all of them together to produce pressure. So it's a what? A derived quantity. Please take note of that. Pressure is something that what? Very vital in our environment. So pressure is something that is very vital. Now, please take note, because of some professional exam, pressure can be like in the world. Now look at the board. Though. I told you dVg abi over area. Please listen and listen so good. Now, if what? Sometimes they give you maybe they not give you velocity and density. Now look at the board. I can write as d times what? Area times what? Height over what? A times g. This I will cancel this. I will have what? DHG. That is not where I'm going now. Now remember that in motion, v square equal to what? U square plus what? 2as. If you remember, I don't know, or 2gs under gravity. Now let us make gravity the subject of formula. Please take note of that. Let us make gravity the subject of formula. So this one now, let's assume that the body, the car, or the object, your solid object start from rest. So v square equal to what? 2g what? H. Let's call this one H. Now, how do you make G the subject of formula? So G becomes what? V square over what? 2 what? H. Now, let me put the value on that what in that equation. So therefore, we can add under pressure is what? Pressure formula can also be what? What is our D? Density. H times, in place of gravity, let's put what? V square over 2H. What do you have? We cancel this. So pressure equals to what? 1 over 2 dV square. Or some tell you right as 1 over 2 rho V square. Rho is a what? Symbol for density, but I use it as D here. So anyone you choose to use is correct. So please take note of that. This is another formula for pressure. Pressure is equal to what? Half times density times what? Velocity square. Half times density times what? Velocity square. I think we have done for today. We want to now take questions that will back up all these things. Well, we have just 30 minutes to go. They will take questions that back up all these things so that we can understand what we are saying. So now let's take questions. I have just 5 questions here, and we have just 30 minutes. Although they are short questions, so we can back up all this one. So we know when we come next class, and we just know that we are talking about pressure in liquid. Pressure in liquid is part 2. This one is more or less like pressure in solid. So that is it. So we are talking about pressure in liquid. Most times we don't talk about this part. What they talk about is what they just go straight, give you some little things, and people find problem they cannot solve. Now let's see question under this part we have just treated today that we can call it a day. So it has been a very long journey for me. We had a very long journey, or a very strong day, a very joyful day where we had the cultural day, and it was that's why you see me in my attire, my native attire as a Yoruba man. God bless you. And Nigerian, I'm a Nigerian man that is from Yoruba culture. Thank you very much. Now let's continue. We want to take the first questions, and it goes by a plastic. So let me start with this. I think this one will explain the first formulas I gave. Let's take some. Let's take this one first. The stylus of a photograph record exerts a force of 7.7, exert a force of 7.7 times 10 raised power what? Minus what? 7 Newton. Please, I will need I will need calculator. Please help me out. On a what? A groove of radius 10 raised power minus 5 meter. 10 raised power minus 5 meter. Now, compute the pressure exerted by the stylus on the ground, on the groove. Now, what we're going to do now is that no need to waste too much time in the question. There are what they say, stylus of a photograph record exert a force of 7.7 times 10 power minus 7 Newton on a groove of a radius 10 power minus 5 meter. Compute the what? The pressure exerted by the what? By this stylus on the groove. Now the force is already given as what? 7.7 times 10 power minus 7 Newton. Our area is what? Pi r square, because they gave us what? Radius. So the groove, that means a circular what shape. So that means we would have 27 over 7 times what? Pi is 27 over 27 over what? 7, or 3.142. Then 22 over 7 rather. Then times what? 10 raised to power, what the radius there? 10 raised to power minus 5, or what? Square. Pi is 22 over 7 times what? Radius is what? Is given as what? They give us radius as 10 raised to power minus 5 meter. So we square it to get our area. So that will give us what? Our area becomes what? 22 over 7 times what? Then we are going to have what? 10 raised to power minus 10. 10 raised to power minus 10 meter square. So let's take this one as our area because I've got to be provided with calculator. Let's solve pressure. Let me see what I can do there. It's got to force over area. It's got to, we are going to eliminate it anyway. 7.7 times 10 power what? Minus 7 divided by what is area there? 22 over 7 times 10 power minus 10. Don't forget the square. Minus 5 times 2 power multiply power. Then this 7 will go up as what? 7.7 times 7 times 10 power minus 7 divided by what? 22 times 10 power what? Minus 10. Listen so good. I can write this one as what? 77 over what? Over what do you call it? 10 times 7 times what? 10 power minus 7 divided by 22 times what? 10 power minus 10. Which can give us what? Now this 10 will go down, which is 77 times 7 times 10 power minus 7 over 10 times 22 times 10 power what? Minus 10. The 11 here, we are going to have what? 2, because 11 times 2 is what? 22. 11 here, we are going to have it as what? 7. Because 11 times 7 is what? 77. So that one is settled. Then what? 10 times what? 10 is by 1 times 10 is by minus 10. 10 is by 1 times 10 is by minus 10 will give us what? This one, 7 times 7 is what? 49 times 10 is by minus 7 all over. 10 is by 1 times 10 is by minus 10. We are going to have what? According to indices, 10 is by 1 times 10 is by minus 10 is what? 10 is by minus 9. So we are going to have it as what? 2 times what? 10 is by minus 9. And 49 divided by 2 will give us what? 2. We are going to have what? 4.5 times. Then this one now will give us what? Indices will give us 10 is by minus 7 minus 9. Don't forget, according to indices, that will give us 24.5 times 10 is by minus 7 plus 9. And that will give us what? 24.5 times 10 is by what? 2. Because minus 9 plus 7, it will give us what? Ordinary 2. You know why? Because division is minus. This one is means minus what? Because 10 raised to power what? M divided by 10 raised to power n is equal to 10 raised to power m minus n. So what do we now have? We are going to have this as 2450 Newton per meter square or 2450 Pascal. You can press your calculator, and if there's anything you are having that is different from what I have gotten, you can quickly say it now. Number 2 question now. Number 2, this is number 1. Number 2. Now this number 2 now will take care of 2 things. This of me solving 2 questions. I will just solve this one. So that with 3 questions, if there's the 3 important one that will cover every areas that we needed to cover, so that we can have it solved. So this is a question you can screenshot before I clean, so that whenever you want to go through again, you can go through it. Very easy to what? To cope with a class like this. If you don't understand it, you can always go back and solve. That is one beautiful thing about it. Now we'll go to number 2. Number 2 says what? A rectangular what? Block with what? Side 20 centimeter times what? 12 centimeter times 4 centimeter is made of material. Is made of material, and which material? Of density. So they are giving us density now of density 2.0 gram per centimeter cube. So find the what? The minimum what? Pressure it can exert when what? Resting with one of what? Its faces on the what? Horizontal surface. Now, what are the possible faces we can have? Listen, and this is so good. Now, it's a rectangular block. There are possible areas this rectangular block can produce. But first, let us look at the what? The mass. Let's calculate for the mass first. And how do we calculate for mass? Mass is equal to what? It's equal to density times volume. Mass is equal to density times volume. Density is given to us as what? 2.0 gram per centimeter cube. Volume is equal to what? 20 times what? 12 times 4. That's what we are giving, 12.0. So times 4. We're going to be in centimeter cube. So if you do that, 4 times, this one will give us what? 240. Then 240 times what? 4 will give us what? 16. 9 what? We have what? 16 carry 1, 8, 9, 960 centimeter what? Cube. You can confirm it. So if there's any discrepancy there, you can what? Talk. So 12 times 2 is 24. They add 0 by the side, 240. 240 times 4 will give us 96. They add 0 by the side. So that is it. Now, we now get mass is equal to what? What is density now? 2.0 gram over centimeter cube times what? 960 centimeter cube. Centimeter will kill centimeter. So what I would have 960 times 2. 960 times 2. 960 times 2 will give us 12 carry 1. This 18 plus 1 is what? 19. So 12 here carry 1, right? What? 2 carry 1. 18 plus 1, 19. So I would have 192. So M is equal to what? 192 what? 0 what? Gram what? What? As a mass. Now we have gotten our mass now, which is what? 192. Now, if you have gotten your mass as we have gotten our mass now, the next thing we do is to convert to kilogram. Convert it to what? To kilogram. And since we want to convert to kilogram, what do? We are going to what? First of all, divide by 1,000. Recall that what? What we did first was find the volume, which we are what? This times this times this will give us 960. Then number 2 was to what? Convert the density and the volume to mass, which we have done. 2 times 960. Then you confirm it. Whether you are going to have this. Then convert to kilogram by dividing by 1,000. Mass in kilogram. 1, 2, 3. And 1.92 kilogram. That's what we are going to have as in converting to what? To kilogram. If you multiply by 1,000 back, you take it back to normal. Then having convert to kilogram, what do you get again? What we are going to do now is to what? Get our mass in terms of weight or force. What is weight? Weight equal to what? mg. So what is our g? You are not giving. Take g as 10. This time you are not giving. Or you can see is 9.8 times 10. What do you have? 19.2 Newton. Now you have gotten your mass, your weight. Now what did they say we should find? Minimum what? Minimum what? Pressure. Minimum pressure will be produced by maximum area. What are the possible area? Area 1. Let me take this and this. If I take this and this, you give me what? 20 times 12. Give me what? 240 centimeters square. That is area 1. Let me take this and this. That is the possible phases. I'm choking because they said minimum force, minimum pressure it can exert when resting with one of its faces. So that means we don't know the face. Let's solve. A2, what is possible second area? Let's combine this and this. 20 times 4 is what? 20. Let me write it out so that you can see it. 20 times 12. We have 240 centimeters square. Then what? 20 centimeter again times 4 centimeter. We have what? 80 centimeters square. Then what we have again? A3 is what? Which one have we not combined, class? We've not combined 12 and what? So that is what? 12 centimeter times what? 4 centimeter. We're going to have what? 48 centimeters square. That's the last one we've not combined. Now, if you look critically, all these three possible faces that the block, the rectangular block, can produce. Now, which of them will produce the minimum pressure? The minimum, P minimum, is produced by what? The weight divided by what? A max. Then P max, maximum pressure, is produced by the weight over what? A minimum. Please take note of that. A minimum. We have not got into that part, please. We have not. When we come to liquid, we've not got into that. That's where we're going to talk about principle of transmissibility, Pascal principles. We talk about atmospheric pressure. What is atmospheric pressure? These are under liquid. This one is solid. Most of the times, most tests will jump solid. And when you are analyzing solid question, it's as though you are analyzing liquid. That is a mistake many tests will do. They will just leave this part and jump to pressure in liquid. So when I put that topic, many of you saw in the video I posted on Facebook or my TikTok, I posted pressure in solid and liquid. So what I'm doing here now, we check what are we dealing with? We are dealing with a block. I cannot use what? Rho GH, density times gravity times height, to solve question like this, because I'm dealing with what? That formula is what? Purely for what? Derived from density in what? In liquid. I can say so density in solid depends on the cross-sectional area. Yes, so. Yes, so. Density in solid depends on the shape. I just told you that the area, if it's circular, pi r square. If it's what? So that is to tell you that our pressure is force over area. So pressure depends on force and also depends on area of a solid. Now let's go. So that question, just prepare that question, keep it when we get to work, because I'm even running out of time. And there are different questions I want to solve because it's 1 hour. We have just about 15 minutes more. So now, this question now, what did they say we should find out? We need to find minimum pressure. So minimum pressure is what was? The weight, which is what? 19.2 Newton. That is the weight. Then what is the minimum area? If you look at these three, which of them maximum area rather? Which of them have maximum area? 240 centimeter square will be the best one to call. But how do we convert centimeter square to meter square? That is it. 1 centimeter is equivalent to 10 raised to power minus 4 meter square. Please take note of that. So the unit is in centimeter square. You have to convert to meter square. So in doing that, you multiply by 10 raised to power minus 4 meter square. So this centimeter square means 1 centi square meter square. Centi is a word, prefix. Just like we have micro. Micro is 10 raised to power minus 6. Nano, 10 raised to power minus 9. Pico, 10 raised to power minus 12. We have milli, 10 raised to power minus 3. Centi, 10 raised to power minus 2. And so forth and so on. So when you have centimeter square, mean 1 centi square meter square. Permit me to use it like that. So this one, C square is equivalent to 10 raised to power minus 2 all square, because centi is what means 10 raised to power minus 2. So if you square this one, what I would have 10 raised to power minus 4. So what I want to have now is what? We want to have it as what? Pressure, minimum pressure equals to what? 192. This one will go up as what? If you want to remove this minus, you can go up as what? 10 raised to power 4 divided by what? 240. So if you press your calculator now, The pressure calculator, what we are going to have is what? 190.2 times what? 10 raised to 4 divided by what? 240. I come again, 119.2 times 10040 divided by 240. So it will give us what? 800 what? What? Newton per meter square. That's what I want to have. That is the first answer we are going to have for minimum pressure. You can confirm it and let us know. Then what about what? Maximum pressure. If they didn't ask us, but let me solve it. Maximum pressure will be produced by what? Minimum area. What is the most, what? The least area out of the three of them rather. What you have 48 is the what? Least area. So this one will produce what? 19.2 again times what? Or divide 48 times 10 power minus 2 minus 4 meter square. You convert 48 centimeter square to meter square. So what you are going to have is what? What you are going to have is 48 times 10 raised to power minus 4. That is what you are going to have. Consider this, please. Take note. Now, so this one will go up as 19.2 times 10 power 4 to remove the minus, then divide by 48. So what do you have now there, class? 19.2 and 10 by 4 is 10,000. Divide by what? 48. Divide by 48. So what you are going to have now is what? 4,000 Newton per meter square. What about the average pressure? You can do that one by yourself. The average pressure will be between the maximum and what? And minimum, please, I beg you. Average pressure will be between what? Maximum and what? And minimum. Then use 80 to solve. Use 80 to what? To solve that problem. You get your answer. Now, this one is when you are giving pressure and when you are giving density. There is one particular one that is also common, and in most good textbooks, I'm not talking about textbooks, in a very good textbook, you see them, but it's not common in most of textbooks. But in a good textbook, if you want to know a good textbook, you see this question there. Very, very interesting. It's pressure of a solid, not liquid. You understand now? When we get to liquid, what we are going to be using more. That's why we talk about pressure depending on the depth, pressure depending on gases. No, all those ones. But here we are talking about solid. Now, a plastic, number 3. I think this will be the last one. A plastic or block weighing what? 20 Newton has what? Dimension. Has dimension 34 centimeter by what? 25 centimeter by 10 centimeter. What is the greatest? What is the greatest pressure? And the least what? Pressure. Pressure it can exert on the ground. Now, if you check this question where this question on the ground is not talking, it's not, they didn't give us anything like density. They have already given us the direct weight. So I believe this question will not give you problem. What you just need to do is what? Mark what? Get different area. Area 1 is what? 34 centimeter times what? 25 centimeter. Area 2 is what? 25 centimeter times 10 centimeter. Area 3 is what? 34 centimeter times what? I'm taking what? Times 10 centimeter. So this one will give you what? 340 centimeter square. This one will give us what? 250 centimeter square. Then this one will give us what? 0, 2, carry 2. This is what? 15 plus what? Plus 8, gives us 23. Plus 2, 25. carry 2, then 850 centimeters square. That will give us 850 centimeters square. You can confirm it. 34 times what? 25. 850. Very correct. Now let's go. This one will now give us what? We have gotten all the 3 areas sharply. Now let us see how we can get our least pressure. The least pressure will now be what? Let's start with the greatest pressure, the maximum. Maximum pressure is what? The weight over minimum area. That is greatest pressure. What's the weight? 25. We don't need to convert again, like the case where we are giving density. What is the minimum area here? The minimum, the least. The least should be what? 250. Times 10 by what? -4. Don't forget to convert to meter square for centimeter. So that will give us 25 times 10 by 4 divided by 250. And if we do that, 25 cancel, we have 10. Then we have 1,000 Newton per meter square, or 1,000 Pascal. Anyone. The number 2 question says what? Calculate the least pressure. The least pressure. The least pressure will now be what? Maximum area. So A max. So if I want to ask you what is the maximum area among them, 850. So 25 divided by 850 times what is our area in what? Meter square. Is what? Multiplied by 10 to the -4. So for you to convert centimeter square to meter square, you what? You multiply by 10 to the -4, or you divide by 10,000. So what do you have now? Take this one up. We have 25 times 10,000 10 by 4, which is 10,000. 1, 2, 3, 4. Divide by what? 850. So this one will cancel this one. We have 1,000. 5 can go in what? 5 here we are going to have 1 what? 7. So 35. Then 5 here 5. You can divide. So that will be giving us what? 5 times what? Divide by what? Let me just. So that will be giving us 294.17 and 17 Newton per meter square. So that will what I want to have as what? The least what? Then if they ask you for average pressure, we will now use what? 340 to solve average pressure. Average pressure. So now we have solved 3 questions that are very vital to understanding whatever we want to be given. I want to solve the last question, which is very short and precise. Then what you are going to do for me is to practice more questions. This one is different from everything we have been solving. Somebody gave me a question. They wrote an exam in an institution, in which is for those that just finished JAM. They wrote an exam called Chevron exam. And they gave them this question. In fact, that brought me to talk about a formula that is not too common. The students say they have not seen question like that before. So they now send it to me. I said I will bring it to this house. And it started with me pressure. So it's very interesting. Say calculate the pressure exerted on a car by the wind with density 2.0 kilogram per meter cube and traveling with a speed and traveling with a speed of 10 meters per second square. This question looks very, very, that is the last question for the day, that we can call it a day. We have tried. Every other questions are similar questions. Examiner, when they give you mass, you can convert mass to Newton. If they give you mass 2.5 kilogram, convert to Newton. That one is not a problem. Now, they said, well, calculate the pressure exerted on a car by the wind with density. That means this is the density of the car. They give us density and traveling with a speed of what? 10 meters per second square. Now, 10 meters per second, rather, this speed. Sorry, 10 meters per second. Speed, velocity is 10 meters per second, or speed is 10 meters, but acceleration is 10 meters per second square. Now, lastly, what we are going to do to calculate pressure? Pressure is equal to 1 over 2 rho v what square. Pressure equal to what? 1 over 2 what? Rho v square. Sometimes, you know, they have derived this formula, so if you don't understand it, go and we sometimes we write it as what? 1 over 2 dv square. So what we're going to do now, we are giving what? Density as what? 2.00 kilogram per meter cube. We are giving what? Speed, velocity as 10 meters per second square. So what is our pressure to end it for today? Is 1 over 2 times, what is density? Density is given to us. Please don't forget, once you take a parameter, choose a suitable formula and solve. 2 times what? 10 square. So what I would have now, 2 will cancel 2. Don't forget the unit are already in standard unit, kilogram per meter cube. This is meter per second. So what I would have now is what? It's going to be what? 100 what? Newton per meter square. Don't forget that velocity is what? Density is kilogram per meter cube. Times velocity is what? Is meter over second. When you square it, what do you have? You would have about kilogram over meter cube times what? Meter square over what? Second square. Now, why I'm showing you this now, listen so good, is that when you cancel this one now, this one will become meter. Now, dimensionally, it is correct. That is to say, kilogram per meter per second square. Is it not the unit of that pressure? So if you check dimensionally, you notice that this formula is dimensionally accurate with this. Because sometimes when we want to prove a formula, whether it's correct, we use dimensional analysis to prove a formula that it is valid and to prove the correctness of what? Of that formula. So this formula is correct. So that's why we check, I prove it, kilogram per meter cube times meter over second all square. If you do it, you are still going to have your dimension for what? For pressure, which is what? This. ml minus 1, t minus 2. So that is the answer, or we write it as what? 100 Pascal. 100 Pascal. You can write it as 100 Pascal or 100 what? Newton per meter square. I think that will be the last question, which is number 4. I think we have solved 4 questions. I will also analyze this. So when we come next class, what we are going to do now is we are going to look at pressure in liquid. That is another area. Please be prepared for that class. That will be on Wednesday. Please help us spread the news. This is not a tutorial thing. Maybe where we specialize for particular people, set to people. We are working with everybody. You know, that want to understand physics to the basics. In fact, the basic of physics, and also to be able to build from there. So that's what we are all about. And we are not for one person, we are for everybody. So please, for this video class, this online YouTube class by Engineer Holiday, help us spread it so that we can be encouraged, because it's taking a lot from us to organize a class like this. And the only thing we can get back from you is to recommend somebody. Just spread the good news. Tell your friend in Lagos, in Port Harcourt, in Abuja, in Ibadan, in Oyo State. Physics is physics everywhere in the world. So please try to tell other people about this class and subscribe. Click the notification button Watch all our videos that were posted. God bless you as you do that. Thank you very much. Good night, everyone.